There's just a wealth of information to be found in each and every EHEDG guideline document, and that is why in this series I interview contributors, expert contributors to these guidelines, and we zoom in together on a specific section of each guideline to illustrate that practical value. Today, my guest is Francisco Pedrosa. He works for Spirax Sarco, that is a company specialized in the treatment of steam. And the section that we zoom in on is section 9.4 of this guideline, and that deals with steam treatment. Very important topic. Francisco, great to have you with us. What was the goal of the guideline concerning this specific subtopic?
What we try to do is explaining the importance of steam when it's in actually contact with the process. And the guideline gives you all the directions and the thoughts that you should be considered when actually doing a clean steam system.
Is the food industry currently sufficiently aware of the importance of correct steam treatment?
A lot of industries out there are very naive or very confused what is actually clean steam. And the guidance clearly indicates the purpose and the reason behind clean steam versus any other steam in your process.
How can this section 9.4 of this guideline help the readers to validate the hygienic aspects of their steam treatment?
Well, going to be very honest, obviously the purpose of using the EHEDG guidelines, particularly section 9.4, clearly validates the use of steam best practice, ensuring the safety and the security of the process. Ultimately, we're trying to achieve best results in reducing the cost, waste, downtime, and not to forget, the decreasing of carbon emissions by unnecessarily using the boiler overloading. So this is all explained in the guidelines. But it also talks about the dryness and the importance to achieve saturated steam for both the industry plant steam as well as the process steam. It's something that it's neglected within industry. People are not aware how and the importance of dryness is to both the plant and the process. And this guideline clearly indicates that.
Right, let's zoom in on this section now, and more specifically on a diagram that shows a basic configuration of a steam system within a typical food and beverage application. Can you cycle us through the elements of this diagram, please?
It starts off at the boiler house. And it shows you that the hot well in the boiler, it is chemically treated. It has various chemicals because it requires that within the system. So the chemicals are treated within the boiler house, and that actually generates steam into the actual boiler. So that same chemicals, if there is excess chemicals within the actual feed tank, that gets obviously delivered to the actual boiler. When the boiler is generating steam, you're going to get that excess chemicals coming over with the actual steam. Now, the boiler is very difficult to control the actual chemicals carry over within the actual boiler environment, because what happens is the boiler has to react with certain demands of the actual factory or the process. So if the boiler is generating 5,000 tons an hour, then the actual boiler has to accommodate that 5,000 tons an hour at that required pressure. And what happens is the chemical dosage normally gets varied between, obviously, if it's 5,000, there's a certain amount of chemicals that has to be added to contribute or to actually chemical treat the boiler for that loading. But we know that the loading within the boiler, it varies from 50 kilograms an hour up to 5,000 kilograms. So the chemical dosage concentration is very difficult to actually manage. So you get chemical carryover. Then you get the pipe work, you get scale carryover from the scales. And that's why a lot of people put in what they call clean steam filters. Now, the clean steam filters that are into the system, they are there to take away the particulates, not there to take any carryover or actually to take any odors or smell or whatever that can actually appear in the actual steam. Those contaminants such as smell, odors, taints, that can actually still end into the process. You also have the condensate return. So you could get contamination from condensate return. And this diagram again clearly explains that as well on the contamination. But then it also, on the far right-hand side of this diagram, it clearly shows you that using clean steam generator eliminates all those problems. It actually takes away all those issues, all those corrosion, scales, particulates, chemical carryover. It takes away all those issues. And that's why this guidance and this diagram we see here is focusing on actually making sure that the best practice are used for industry. And that is obviously using clean steam.
What about the initial quality of the water that is actually used to produce the steam?
As you mentioned, the actual water, we know that the most important influence in generating steam is the water. And this guideline clearly illustrates that using clean steam is where the water quality is controlled. We know that this steam quality is consistent every time because we have control of that water quality. And this guideline explains to you what type of quality of water is required to be used within clean steam. And it clearly explains the boiler carryover, how harmful the carryover of the chemicals and what, because we all know that chemicals within a boiler steam generation varies depending on the boiler demand. So this guidelines encourage you and introduces these guidelines to make sure that you eliminate these contaminants that occur within actually boiler chemicals and carryover into the process. So this guideline clearly gives you that indication.
One of the additional aspects mentioned in this section of the guideline is about the mechanical correctness of the design used to purify and produce clean steam. How can we achieve this so-called mechanical correctness in real life?
Very interesting. Obviously, the guideline clearly directs and explains the importance of the mechanical correctors. Now, what we talk about mechanical correctors is actually gives you the guideline gives you the clear indication what is mechanical correctors. Now, we always compromise on cost to make sure that we get a steam system installed, but we don't think about removing the condensate quick enough. We don't think about the actual crevices or the dead legs that are into the system. And this is what we talk about, the mechanical correctness. Now, the guideline shows you applying the hygienic design principles on a steam distribution sign system gives you that impact of both the quality and the purity of the steam. So this guideline clearly directs you by using and correcting the mechanical correctors of a plant and using the right hygienic design principles, it actually definitely improves the quality and the purity of steam.
Thank you very much, Francisco, for explaining this particular section of this guideline.
Excellent. Thank you so much. Lovely speaking to you all.
Dear viewer, this was just a very small section of this very comprehensive and valuable guideline. If you want to know more about water treatment, steam treatment, look into it. If you're an EHEDG member, you can download the guideline for free from the EHEDG website. And if you're not an EHEDG member yet, you can pay for the guideline. But when you download 2 or 3 guidelines, it's better to just become a member and get free access to all of them. Thank you very much for watching. See you next time.